In Chapter 3, we were introduced to functions and function notation. In 4.1, we will talk about linear functions. So let's start with the slope of a line. The slope of a line is given as the rise over the run. The rise is the change in y's, the run is the change in x's. So the slope can be written as y2 minus y1, or the change in y's, divided by x2 minus x1, or the change in x's. And the equation of a line is in the form y equals mx plus b. But in this section, because we are using function notation, instead of y, we will use f of x. And remember that y and f of x are interchangeable. Y is equal to f of x. So instead of writing y equals mx plus b, we will write f of x equals to mx plus b. Let's take a look at this example. A city's population in the year 1954 was 490,500. In 1983, the population was 497,750. At what rate is the population changing? And is the population growing or declining? Well, we can see that from 1954 to 1983, the population changed from 490,500 to 497,750. So the population is clearly increasing. But we want to look at that in terms of slope. So anytime we're talking about the rate of change that's linear, that's going to be your slope. Okay? So at what rate is the population changing? So because we're looking at the rate of change, a linear rate of change, we're going to be looking at the slope. So our slope is going to be y2 minus y1 divided by x2 minus x1. But for that, we need to identify our x and y values. So let's take each point and write that as an x and a y value. So our first point is 1954, comma 490,500, and our second point is 1983, comma 497,750. So this is your x1, y1. This is your x2, y2. Now let's simply plug this in. So we have our y2, which is 497,750, minus our y1, which is 490,500, divided by our x2, which is 1983, minus x1, which is 1954. Now you can put this in a calculator. When you do that, you just be careful to use parentheses for each the numerator and denominator. Otherwise, you will have a calculation error. So the numerator is going to be parentheses. So anytime you put this in a calculator, put parentheses 497,750 minus 490,500. And on the denominator, you're going to divide that by, once again, please use parentheses, 1983 minus 1954. And this gives you a slope of 250. And because the slope is positive, the population is growing. If the slope was negative, we would say the population is declining. And to interpret, here's what this is saying, that the population is changing by 250 people per year. Remember, the slope is the rate of change. So this is like saying 250 over 1. So the population is increasing by 250 people for every 1 year. But the important thing here is to remember to take each set of points and writing them as an ordered pair. Let's take a look at the next example. A town's population has been growing linearly. So linearly, this is when we can use f of x equals to mx plus b. In 2003, the population was 54,000, and it's been growing by 732 people per year. So this is your rate of change. How fast is or how much is the population changing per year? And rate of change is same thing as slope. Slope is how fast is the population changing. So let's write an equation for the population P, x years after 2003. So P of x, which is the population of x, equals to In 2003, the population was 54,000. So that is going to be the initial population. Notice that this doesn't have a variable attached to it because that's just the initial population in 2003. Now, every single year, the population is growing by 732 people. So that'll be 732x. If you want to write that in the form y equals mx plus b, you can rewrite that as p of x equals to 732x plus 54,000. But either form will be fine. What is the initial population in 2003? Well, the initial population in 2003 is 54,000. This is like the b value. What is the rate of change? So every year, how much is the population changing by? It's changing by 732 people per year. And that is your rate of change, or the slope. Now let's find the town's population in 2009. So our equation is this. Our equation is p of x equals to 732x plus 54,000. Now remember, where x is the number of years after 2003. So x is the number of years after 2003. So in 2009, the value of x is going to be 2009 minus 2003. It's a number of years since 2003. So in other words, x equals to 6, because in 2009, 6 years have passed after 2003. So we're going to say, what is a population 6 years after 2003, which is 2009? So this will be 732 times 6 plus 54,000. So let's put that on a calculator. We got 732 times 6 plus 54,000, and that gives you 58,392. And just remember that x is the number of years after 2003. So when 6 years have passed, the population will have increased to 58,392. And for any number in math that is associated with the unit, you have to also include the unit. So we're not just talking about some random number. This is the number of people. So we will say that there were 58,392 people in 2009. Right? The next one says, what is the town's population? Or sorry, in what year is the town's population 62,052? Now remember, P of x, this whole thing, this entire left-hand side represents the population. So we want to know in which year is the population 62,052. So instead of P of x, the population, I'm going to replace that by 62,052. The entire left-hand side represents the total population. And that equals to 732x plus 54,000. Now let's do some quick algebra. Let's subtract both sides by 54,000. So this gives you 8,052 equals to 732x. And then of course we will divide both sides by 732. And this gives you x equals to 11. Now it doesn't ask you after how many years. It says in what year. So x represents the number of years after 2003. So 11 years have passed since 2003 for us to get to that population. So we're going to take 2003, add 11 to it, and this will give you 2014. So in 2014, the population is 62,052. Okay, so this next example, we will do this one in class. Let's take a look at the next one. Find the equation of the line in terms of x with f of negative 2 equals to 1 and f of 2 equals to negative 11. So a quick recap. In this notation, f of x equals to y, the parentheses contains the input or the x value, and the result is the output or the y value. So we can take any point in the notation f of x equals to y and write that as an ordered pair. So when we have f of negative 2 equals to 1, the x value or the input is equal to negative 2, and the output or the y value is equal to 1. Same thing over here. The x value is 2, and the y value is negative 11. So using this, let's find the equation of a line. Step 1, find the slope. The slope equals to y2, which is negative 11, minus y1, which is positive 1, divided by x2, which is positive 2, minus x1, which is negative 2. So negative 11 minus 1, that's negative 12. 2 minus negative 2, that's 4. And negative 12 divided by 4, that's negative 3. So our equation now becomes y equals to negative 3x plus b. But in order to solve for b, we still have to plug in the x and y values. So you can choose either point. I'm just going to go with the first point here. So in my first point, my y value is 1, and my x value is negative 2. And everything else stays the same. So I'm going to say that 1 equals to negative 3 times x, which is negative 2, plus b. So I have 1 equals to 6 plus b. I subtract 6 from each side, and I end up with b is equal to negative 5. So my answer, if I put this all together, is going to be y equals to negative 3x minus 5. But notice we're using function notation. So instead of y, I'm going to say that f of x equals to negative 3x minus 5. Okay, let's start this next one, and then we'll finish this in class. So a clothing business finds there's a linear relationship between the number of shirts N it can sell and the price P it can charge per shirt. In particular, historical data shows that 3,000 shirts can be sold at a price of $22 and 4,000 shirts can be sold at a price of $14. So give a linear equation in the form of P equals to Mn plus B. So you got to think of it like this. This is in the form of y equals to mx plus b. So the price P, that's like the y variable, and the N, the number of shirts, that's like the x variable. Okay, so let's go ahead and write each of these as two ordered pairs. So historical data shows that 3,000 shirts can be sold at a price of $22. Now remember, y is equivalent, so this P is the same as y. So when we write this, the price is going to be like your y variable, and the number of shirts is going to be like your x variable. So your first ordered pair is going to be 3,000, 22. In your second ordered pair, the number of shirts is your x value. So this is going to be your input is 4,000 and your output is 14. So that is your y value. Now let's start the problem. So step 1, we need to find the slope, which is y2 minus y1 divided by x2 minus x1. So 14 minus 22, that is negative 8. And 4,000 minus 3,000, that is equal to 1,000. And in this case, let's just deal with decimals. So we have negative 8 divided by 1,000, which is negative 0.008. That is your slope. Let's plug this in. We got y equals to negative 0.008 times x plus b. And I'm using y and x, but I'm going to change to p and n at the end. So let's plug in either point. Let's go with the first one. So the y value is 22, and the x value is 3,000 plus b. So if we take negative 0.008 and we multiply that by 3,000, this gives you negative 24. So we have 22 equals to negative 24 plus b. We will add 24 to both sides, and this will give you b is equal to 46. So our equation is y equals to negative 0.008x plus 46. But in the form p equals mn plus b, we're going to say the price equals to negative 0.008 times n plus 46. And the next part we will do in class.